We are looking to find some key characteristics of this function here. So our first step, as always, is going to be to factor this function. So let's start with the numerator here. We have x cubed plus x squared minus 6x. We can factor out an x from all of those terms, which would leave us with x times x squared plus x minus 6. We can now factor what's in our parentheses here. If we use our diamond method, in the top quadrant, we are going to put -6. In the bottom, we are going to put 1. That is our b term. The factors of -6 that add to equal +1 are going to be 3 and -2. And because our lead coefficient is 1, we can go ahead and write our numerator here. We can write this function in factored form by adding these factors 3 and -2 to x. Numerator, that would leave us with x times x times x minus 2, x plus 3. We factored our numerator. Let's move on and look at our denominator. Denominator, we have -3x squared plus 27x. We could factor out a -3 from both of those terms. And so that would leave us with -3x. We could factor out a -3x from both of those terms, which would leave us with x minus 9. So in our denominator, we would have -3x times x minus 9. So looking at part A here, we can find our discontinuities by finding the values of x that will make our denominator equal to 0. So those values of x are going to be where x is equal to 0 and x is equal to 9. Because when we substitute 9 into our function here, this factor, x minus 9, is equal to 0. And when we substitute 0 in for x, this factor here, -3x, will also be equal to 0. So now to determine whether they are wholes or vertical asymptotes, we are going to look and see whether they occur in just our denominator or both our numerator and our denominator. So x, our factor x, occurs in our numerator as well as our denominator, meaning that when x is equal to 0, both our numerator and denominator will be equal to 0, meaning that this is a whole. Now when x is equal to 9, only our denominator is going to be equal to 0. X minus 9 does not occur in our numerator as well, so we know that x equals 9 is a vertical asymptote. We know that x-intercepts occur when y is equal to 0, so we can find our x-intercepts by setting our numerator equal to 0 and solving for x. So we know that our numerator, and therefore our entire function, will be equal to 0 when any of these factors here are equal to 0. So when x is equal to 0, when x is equal to 2, and x is equal to -3. These are the values of x that will make our numerator equal to 0. But x-intercepts can only occur at defined points on our graph, meaning that they cannot occur at wholes. We know that x equals 0 is a whole, meaning that it makes both our numerator and our denominator equal to 0. So we cannot have an x-intercept where x is equal to 0 because we have a whole at that point. But that leaves us with x equals 2 and x equals -3. So we know that we have x-intercepts at the point 2, 0 and -3, 0. So our final question, we want to determine whether this function has a y-intercept. And we know that y-intercepts occur where x is equal to 0. But we know that when x is equal to 0, we have a discontinuity. So because x equals 0 is one of our restricted values, there's a hole at x equals 0, we do not have a y-intercept. X equals 0 is a restricted value. So we do not have a y-intercept. So we have now found 3 of the key characteristics of this rational function.